And now in this lecture I'll answer two questions. In the first question we'll find out the radius of this circle, and in the second question we'll find out the area of this semicircle APB. So let's start with the first question. In the drawing we have a circle. This is line segment CP. This is equals to 12 units in this length. This is line segment PB. This is equals to 4 units in this length. This is angle CPB. This is equals to 60 degrees in size. And this is line segment AP. This is equals to 3 units in its length. Again, our test is to find out the radius of this circle. So, first of all, it is given us the question that AB is a straight line. So if you focus on the upper side of the straight line AB at point P, here the sum of the angles must be equal to 180 degrees according to Rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point B? We have this angle that is equal to 6 degrees in its size, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to Rule 3. Therefore, this missing angle must be equal to 120 degrees in its size. The next step, we'll join point C and A together by straight line. And we join point C and B together by straight line. So by doing those constructions, we can do those two small triangles, and also the big triangle ABC that contains those two triangles. So in the next step we will implement the law of cosines in this triangle APC. And again we will implement the law of cosines in this triangle APC. So repeat quickly on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC that could be any triangle. Side AB of this triangle ABC equals to a unit in its length. Side AB of this triangle ABC equals to a unit in its length. Side AC equals to B units in its length. Side BC equals to C units in its length. And this is angle BAC is equals to theta degrees in its side according to our definition. So in this triangle ABC that could be any triangle, the following equation is true. C squared equals to A squared plus B squared plus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared plus 2 times A times B times cosine theta. So you can actually implement the law of cosines in this triangle ACP. So implement the law of cosines in this green triangle APC. Angle theta is this angle APC. This equals to 120 degrees in its size. So in this green triangle APC, according to the law of cosines, the following equation is true. CA squared equals to PC squared plus AP squared minus 2 times AP times PC times cosine 120 degrees. And again, according to the law of cosines, this triangle APC, the following equation is true. CA square equals to PC square plus AP square minus 2 times AP times PC times cosine 120 degrees. CA is the missing side, so we leave it as it is. So it is CA square equals to PC square. PC is 12, therefore PC square is 12 squared, that is 144. Plus AP square. AP is 3, therefore AP square is 3 squared, that is 9. Minus 2 times AP, that is 3, times PC, that is 12, cosine 120 degrees. Cosine 120 degrees is minus 1/2. So now we know that CA square equals to 144 plus 9 is 153. And we have minus times minus is plus. So it is, we have 2 in the numerator, so 2 will get cancelled. So here in total we have 3 times 12, that is 36. This is plus 36, because minus times minus is plus. So in total we know that CA square equals to 133 plus 36. Actually it is 144 plus 9 is 153. 153 plus 36 is 189. So in total we know that CA square equals to 189. Here we take a root out of this equation, and finally we get that CA equals to the square root of 189 units in its length. Side CA equals to the square root of 189 units in its length. This is side CA. This equals to the square root of 189 units in its length. So it is known. Likewise, we will implement the law of cosines in this white triangle CPB. We will take theta as this angle is 60 degrees inside, angle CPB. So this triangle PCB, according to the law of cosines, the following equation is true. CB square equals to PC square plus PB square minus 2 times PC times PB times cosine 60 degrees. Then again, according to the law of cosines, this triangle PCB, the following equation is true. CB square equals to PC square plus PB square minus 2 times PC times BB minus 2 times PC times PB times cosine 60 degrees. CB is the missing side, so leave it as it is. So it is CB square equals to PC square PC is 12, therefore PC squared is 12 squared, that is 144. Plus PB squared. PB is 4, therefore PB squared is 4 squared, that is 16. Minus 2 times PC times PB times cosine 60 degrees. So it is minus 2 times PC is 12 times PB is 4 times cosine 60 degrees. Cosine 60 degrees is 1/2. So today we found out that CB squared equals to 144 plus 16 is 160, and it's equals to, here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with 12 times 4, that is 48, so it is minus 48. So in total we found out that CB squared equals to 160 minus 48, that is 112. CB squared equals to 112. Here we take a root out of this equation, and finally we get that the length of side CB is equal to the square root of 112 units in its length. Again, we found out that the length of this side CB equals to the square root of 112 units in its length. In the next step, we will implement the law of cosines in this big triangle ABC that contains those two smaller triangles. So according to the law of cosines, in the big triangle ABC, we'll choose angle alpha, and this angle so angle theta in the law of cosines is equal to angle alpha. So here we get that according to the law of cosines, if we implement the law of cosines in this big triangle ABC, CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. So if again according to the law of cosines, this triangle ABC, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We already found out that CB squared equals to 112. So let's substitute CB squared by 112. And it's equals to CA squared. CA is the square root of 189, so CA squared is 189. Plus AB squared. AB is 3 plus 4, that is 7. So AB is 7, therefore AB squared is 7 squared, that is 49. minus 2 times CA times AB times cosine alpha. So it is minus 2 times CA. CA is square root of 189 times AB. AB is 7 times cosine alpha. So today we found out that 112 equals to 189 plus 49 minus 2 times square root of 189 times 7 times cosine alpha. So 112 equals to 189 plus 49 is 238. Here we have minus 2 times 7 is minus 14 times square root of 189 times cosine alpha. So here we subtract 112 from this equation, and you get that in this side of the equation we left with nothing, that is to say 0. And on the other side of the equation we have 238 minus 112 is 126 minus 14 times the square root of 189 times cosine alpha. So here we will add to this equation 14 times square root of 189 times cosine alpha. So here we have 14 times the square root of 189 times cosine alpha. And on the other side of the equation we left only with 126. So here we will divide this equation by 14. So here 14 will get cancelled, and we left only with square root of 189 times cosine alpha. Here we have 126 over 14 is 9. So today we found out that the square root of 189 times cosine alpha equals to 9. Here we divide this equation by square root of 189, and finally get that cosine alpha equals to 9 over square root of 189. So cosine alpha equals to 9 over square root of 189. We substitute 189 by 9 times 21. And we get that cosine alpha equals to 9. The square root of 9 is 3, so we'll take 9 out. We'll take 9 out of the root. So inside the root we left only with 21. So today we found out that cosine alpha equals to 9 over 3 times square root of 21. Here we divide both the numerator of this expression by 3. We get that cosine alpha equals to 9 over 3 is 3. and here 3 will get cancelled, and we left only square root of 21. So in total, if you found out that cosine alpha equals to 3 over square root of 21. Okay, again, in total, if you found out that cosine alpha equals to 3 over square root of 21. Here, we use the following trigonometric identity. Here TA is the relation for trigonometric identity. So the trigonometric identity is as follows. Sinus square alpha plus cosine square alpha equals to 1. So here we subtract cosine square alpha from this equation. We get that sinus square alpha equals to 1 minus cosine square alpha. Here we take a root out of this equation, and finally get that sinus alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. Okay, again, we already found out that cosine alpha equals to 3 over square root of 21. And therefore cosine square alpha will be equal to 3 squared, that is 9, over square root of 21 squared, that is 21. So today we found out that cosine square alpha is equal to 9 over 21. So here we have the equation that says that sinus alpha equals to the square root of 1 minus cosine square alpha. So sinus alpha equals to the square root of 1 minus cosine square alpha. The cosine square alpha is 9 over 21. So if I know that sinus alpha equals to the square root of, here we multiply 1 by 21 and then we divide it by 21 in order to a common factor with this number. So it is 21 minus 9 over 21. So sinus alpha equals to the square root of 21 minus 9 is 12 over 21. Here we divide both the amount of this number by 3 and get that 12 over 3 is 4 and 21 over 3 is 7. So here we take 4 out of the roots, the square root of 4 is 2. So sinus alpha equals to 2, inside the roots we left only with 7. So today we found out that sinus alpha equals to 2 over square root of 7. Sinus alpha equals to 2 over square root of 7. So in the next step, we implement the law of sines on this triangle ABC. So if we click on the law of sines, according to the law of sines, first of all, the law of sines is true in any triangle. This is triangle ABC that could be any triangle. The length of side AB is C units in its length. Side AC equals to B units in its length. Side AB equals to A units in its length. Angle BAC equals to capital A degrees in size. Angle ABC equals to capital B degrees in size. Angle ACB equals to capital C degrees in size. And you also know that the radius of this circle that blocks this triangle ABC is equal to R. So according to the law of sines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks this triangle ABC. So again, according to the law of sines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks this triangle ABC. If you implement the law of sines, this triangle ABC, the big triangle ABC. According to the law of sines, this big triangle ABC, the following equation is to CB over sinus alpha equals to 2R. And again, in the big triangle ABC, according to the law of sines, the following equation is to CB over sinus alpha equals to 2R. R is the radius of this circle. That is the radius that we are looking for in this question. So we have CB. CB is equal to 112. Or sinus alpha. We already found out that sinus alpha equals to 2 over square root of 7 units, and 2 over square root of 7. And is equals to 2R. And again, for another period, the square root of 112 over 2 over square root of 7 equals to 2R. So here we have square root of 112. We substitute 112 by 16 times 7 again. We substitute 112 by 16 times 7. And we get that 16 times 7, root of 16 times 7 over 1 over 2 times square root of 7 equals to 2R. We know that the square root of 16 is 4, so we take 4 out of the 16 out of the root. So inside the root, left only with 4 times square root of 7 over 2 over square root of 7 equals to 2R. Here we will move 7, square root of 7 to the denominator and to the denominator, and we get that 4 times square root of 7 times square root of 7 over 2 equals to 2R. 4 over 2 is 2. So today we should find out that 2 times square root of 7 times square root of 7 equals to 2R. Here we divide this equation by 2, and we get that square root of 7 times square root of 7 is 7. So in total this expression equals to 2 times 7 equals to 2 hours. Here we divide this equation by 2, so we get that R, that is the radius of this circle, that is the radius that we are looking for this question, is equal to 7. Or equals to 7 units inside. Again, if you find out that the radius of this circle, the radius R equals to 7 units in itself. So we finish with the first question. The next step, I will present you the second question, and we solve the second question of this lecture. Our task in this question is to find out the area of this semicircle APB. So in the drawing we have a semicircle. We know that side PC or right side PC equals to 21 units in its half, right side PQ equals to 16 units in its half. This is angle CPQ. Equals to 90 degrees in size. Again, and we also know that AC equals to 7 units in itself. Again, our test is to find out the area of this semicircle APQB. Okay. We define the radius of this semicircle as x. So the diameter AB equals to 2x and CB equals to AB minus AC. So CB, this is right side CB, this equals to AB is 2x minus AC, that is 7. So if you found out that CB equals to 2x minus 7 units in itself. In the next step, we will complete this semicircle to a circle. So I completed the semicircle to a circle, and we will extend line segment PCU by side line until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. We define the length of this line segment CM as A. So here we can implement rule 65 in our drawing. So please quickly on rule 65. According to all, first of all 65 is true in any circle. This circle could be any circle. If chord AB intersects with chord CD at point O, then the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So in the moment we have a circle, this is chord AB that intersects with chord CD at point O. So according to this rule 65, AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement all 65 in our drawing. In our drawing, this is chord AB, intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. So I did down. Chord AB intersects with chord PM at point C. This is point C. Again, chord AB intersects with chord PM at point C. Therefore, according to rule 65, the following equation is true. AC times CB equals to PC times CM. And again, according to rule 65, the following equation is true. AC times CB equals to PC times CM. AC equals to 7 times CB. We already found out that CB equals to 2x minus 7. And it equals to PC. PC is 21 times CM. CM is A. So to the, if you found out that according to rule 65, 7 times 2x minus 7 equals to 21a. Here we divide this equation by 7. If we get that here 7 gets cancelled, we have to leave 2x minus 7 equals to 21 over 7 is 3. So in total, this equation equals to 3a. So in total, if you found out that 2x minus 7 equals to 3a. Here we add to this equation 7, and we get that 2x equals to 3a plus 7. Again, in total, if you found out that 2x equals to 3a plus 7. In the next step, we'll join points Q and M together by a straight line. By joining points Q and M, we can do the right line MPQ. This is the right line MPQ. This is actually the center of the circle, so when you find the center of this circle, this point is point O. This is Triangle QPM. And again, this is triangle QPM. Angle QPM is right angle. Yeah. This is triangle QPM, that is right angle. According to what is given as the question, triangle QPM subset on code QM. Again, triangle QPM subset on this code called QM. So you can implement all 5 in our drawing. According to all 5, repeat quickly on all 5. According to all 5, any peripheral angle that is equal to 90 degrees in size must subtend on the diameter of the circle. This is peripheral angle MAN that is equal to 90 degrees in size, and it subtend on chord AN that is indeed the diameter of this circle. So according to rule 5, any peripheral angle that is equal to 90 degrees in size must subtend on the diameter of the circle. So can implement all 5 in our drawing? Why? Because in our drawing, this is peripheral angle MPN that is equals to 90 degrees inside, and therefore it must subset on the diameter of the circle. Peripheral angle PM, peripheral angle MPQ, that is right angle, subset on chord QM. Therefore, according to all 5, because of the fact that peripheral angle MPQ is a right angle, it must subset on the diameter of the circle. Peripheral angle MPQ subset on QM, and therefore, according to all 5, QM must be the diameter of the circle. So now this is this is called QM, that is the diameter of this circle according to rule 5. But we already found, according to our definition, the radius is x, therefore the diameter is 2x. Okay? The radius is x, therefore the diameter must be equal to 2x. So in the next step, we'll implement the Pythagoras theorem on this green triangle PQM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this green right triangle MPQ, here by PT is the relation for Pythagoras theorem. So according to the Pythagoras theorem, this again right triangle MPQ, QM squared, that is the square of the hypotenuse, equals to PQ square plus PM square. And again, MPQ according to the Pythagoras theorem. QM square, that is the square of the hypotenuse, equals to PQ square plus PM square. QM is 2x, therefore QM square is 2x squared. And it equals to PQ. PQ is 16, therefore PQ square is 16 squared, that is 256 plus plus PM square. PM in total is 21 plus 8, therefore PM square is 21 plus 8 square. So in total, we found out that in the right triangle MPQ, the following equation is 2x squared equals to 256 plus 21 plus 256 plus 21 plus 8 square. Actually, we already found out that 2x equals to 3a plus 7, therefore we substitute 2x here by 3a plus 7. So it is 2x squared. So we have to square 3a plus 7 squared. is equals to 256 plus 21 plus a squared. 21 plus a squared equals to 21 squared, this is 441 plus a squared, minus 2 times 21 times 2 is 140, plus 2 times 21 times 2 is 4, plus 2 times 21 times a is 42a. So we found out that 3a plus 7 squared equals to, we have 256 plus 441 is 697 plus a squared plus 42a. So here we open the brackets on this side of the equation. And we found out that 3a plus 7 squared is 3a squared. This is 9a squared plus 7 squared, this is 49, plus 2 times 3a times 7, 2 times 3a is 6a, and 6a times 7 is 42a, and it equals to 697 plus a squared plus 42a. So first of all, on both sides of this equation we have 42a, so 42a will get cancelled. In the next step we subtract a squared for this equation. So a squared will get cancelled, and 9a squared plus a squared is 8a squared. So 8a squared plus 49 equals to 697. So here we subtract 49 from this equation. And finally we get that 8a squared equals to 697 minus 49 is 648. So in total we found out that 8a squared equals to 648. Here we divide this equation by 8 and finally get that a squared equals to 648 over 8 is 81. So a squared equals to 81. Here we take out all of this equation. And we get that a equals to, the square root of 81 is 9. So a equals to 9 units and it's 9. But we only found out that 2x equals to 3a plus 7. So copy this equation here. 2x equals to 3a plus 7. So 2x equals to 3a. A is 9, therefore 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 38. 34. So 2x equals to 34. Here we divide the equation by 2 and we get that x, that is the radius of the semicircle, that is the radius that we are looking for in this question, is equal to 34 over 2 is 17. So x, the radius x of the semicircle, equals to 17 units in its length. The radius of this semicircle, x equals to 17 units in its length. Our test is to find out the area of this semicircle, APQB. So what is the area of the semicircle? the radius of this semicircle is x, therefore the area of the semicircle must be equal to pi x squared over 2. So again, the area of this semicircle equals to pi x squared over 2. So it is pi over 2 times x squared. X is 17, therefore x squared is 17 squared. So today we found out that the area of the semicircle equals to pi times 17 squared over 2. So it is pi over 2, and 17 squared is 289. So today we found out that the area of this semicircle is equal to either 289 pi over 2 square unit in size, or in terms of numbers it is equal to 453.96 square units in size. But again, the area of this semicircle, that is the area that we are looking for this question, is equal to either 289 pi over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in size. Okay, so finish with the second question. The next step after the lecture, we start with the repetition of the solution of the first question, and then we repeat on the solution of this second question. The first question, our task was to find out the radius of this circle. So in the drawing we have a circle. This is line segment CP, this is equals to 12 units in its length. This is line segment PB, this is equals to 4 units in its length. This is line segment AP, this is equals to 4 units in its length. This is again CPB, this is equals to 60 degrees inside. Again, our task is to find out the radius of this circle. So we have here it is given as a question that AB is a straight line. So if we focus on the upper side of the straight line AB at point P, here the sum of the angles must equal to 180 degrees according to all three. All three sides, the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point P? We have this angle, equals to 60 degrees in size, plus this missing angle, total the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 120 degrees in its size. In the next step, we join point C and A together by straight line, and point C and B together by straight line. So when doing those constructions, we get there the green triangle CAP, and the white triangle CPB, and the big triangle CAB. We have three triangles. So in the first step, implemented the law of cosines in this green triangle, triangle CAP. So a bit quicker on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC, that could be any triangle. The graph of side AB on this triangle ABC is equals to A unit in itself, side AC equals to B unit in itself, side BC equals to C unit in itself. This is angle BAC, that is equals to theta in its size. So this triangle ABC, that could be any triangle, the following equation is to C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So we can actually implement the law of cosines in this triangle CAP. So according to the law of cosines, if we take theta as this angle is 120 degrees in its size, we get that according to the law of cosines, the following equation is to CA square equals to AP square plus PC square minus 2 times AP times PC times cosine 120 degrees. Repeat again, according to the law of cosines, in this green triangle APC, the following equation is to CA square equals to PC square plus AP square minus 2 times AP times PC times cosine 120 degrees. CA is the missing side, so we leave it as it is. So it is CA square equals to PC square. PC is 12, therefore PC square is 12 squared, that is 144, plus AP square. AP is 3, therefore AP square is 3 squared, that is 9. So here we found out that CA square equals to 144 plus 9 minus 2 times AP, that is 3. So it is minus 2 times 3 times PC, that is 12 times cosine 120 degrees. So it is minus 2 times 3 times 12. And cosine 120 degrees is minus 1 half. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. Minus times minus is plus. So here we have 144 plus 9 is 153. And 3 times 12 is 36. It is plus 36. So total, if you found out that CA square equals to 153 plus 36. 153 plus 36 is 189. So if you found out that CA square equals to 189, here we took out of the equation, and we found out that CA equals to the square root of 189 units in itself. This is side CA, equals to the square root of 189 units in its length. Likewise, we implemented the law of cosines in this triangle CPA, the right triangle CPA. We took theta as 60 degrees. Again, theta equals to 60 degrees, according to our choice. So in this triangle CPA, according to the law of cosines, the following equation is to CB square equals to CP square plus PB square minus 2 times CP times PB times cosine 60 degrees. And again, according to the law of cosines, in this right triangle CPB, the following equation is to CB square equals to PC square plus BB square minus 2 times PC times PB times cosine 60 degrees. CB is the missing side, so we leave it as it is, and it is equals to PC square. PC is 4, therefore PC square is 4 squared, that is 16, plus CP square. CP is 12, therefore CP square is 12 squared, that is 144. So in total, if you know that CP square equals to 144 plus 16, minus 2 times PC, that is 4, times minus 2 times PB, that is 4, times PC, that is 12. So it is minus 2 times 12 times 4 times cosine 60 degrees. Cosine 60 degrees is 1 half. So in total, if you know that CB square equals to 144 plus 16 minus 2 times 12 times 4 times 1/2. We have 2 in the numerator, 2 in the denominator, so 2 get cancelled. In total, if you want to know that CB squared equals to 144 plus 16, that is 160. Here 2 will get cancelled, we have only 12 times 4, that is minus 48. Minus, which is minus 48. 12 times 4 is minus 48. Because we have minus before 12. So it is minus 48. So in total, if you want to know that CB squared equals to 160 minus 48, that is 112. Here we took out all those equations, but we found out that CB equals to the square root of 112 units in its length. This is side CB. This is equals to the square root of 112 units in its length. Likewise, in the next step, we implemented the law of cosines in this big triangle ABC. We define this angle as alpha. This is to say angle CAB equals to alpha degrees inside according to our definition. So, in the equation of the law of cosines, angle theta is angle alpha. Therefore, according to the law of cosines, this triangle ABC, the following equation is to CB squared equals to CA squared plus AB squared minus 2 times CA times CB times cosine alpha. With again, according to the law of cosines, this triangle ABC, the following equation is 2. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We already found out that CB squared equals to 112 and it equals to CA squared. CA squared is 189 plus AB squared. AB is 7, therefore B squared is 7 squared, that is 49. So total we found out that 112 equals to 189 plus 49 minus 2 times CA times AB times cosine alpha. So it is minus 2 times CA is square root of 189 times AB to the 7 times cosine alpha. So we found out that 189 plus 49 equals to minus 2 times square root of 189 times 7 times cosine alpha. So 112 equals to 189 plus 49 is 238. And we have minus 2 minus 7 is minus 14 times square root of 189 times cosine alpha. So here we subtracted 112 from this equation. We found out that this is the equation left is nothing, that is to say 0. While on the other side of the equation we have 138 minus 112 is 126 minus 14 times square root of 189 times cosine alpha. So here we added 14 times square root of 189 cosine alpha to this equation. If I found out that 126 equals to 14 times square root of 189 times cosine alpha. Here we divided this equation by 14. If I found out that the square root of 189 times cosine alpha equals to 126 over 14 is 9. So if you found out that the square root of 189 cosine alpha equals to 9. Here we divided this equation by square root of 189. If I found out that cosine alpha equals to 9 over square root of 189. So cosine alpha equals to 9. We substitute 189 by 21 times 9. So here we have cosine alpha equals to 9 over 9 times 21. The square root of 9 is 3, so we took 3 out of the root. So inside the root we left only 21. So in total if you found out that cosine alpha equals to 9 over 3 times square root of 21. Here we divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3, and here 3 we get cancelled and left only square root of 29. So in total, if you found out that cosine alpha equals to 3 over square root of 29. We use the trigonometric identity that says that sine square alpha plus cosine square alpha equals to 1. Here we subtracted cosine square alpha from this equation. If we found out that sine square alpha equals to 1 plus cosine square alpha. Here we took out of this equation. If I found out that sine alpha equals to the square root of 1 plus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. Therefore, cosine square alpha must be equal to 3 squared, that is 9, over square root of 21 squared, that is 21. So in total, we found out that cosine square alpha equals to 9 over 21. We get cosine square alpha equals to 9 over 21. We only found out that sine alpha equals to the square root of 1 times cosine square alpha. So sine alpha equals to the square root of 1, and cosine square alpha is 9 over 21. Here we multiplied 1 by 21 and then we divided by 21 in order to overcome factor with this number. So it is 21 minus 9 over 21. So in total we found out that sine alpha equals to 21 minus 9 over 21. 21 minus 9 is 12 and 12. So in total this expression equals to the square root of 12 over 21. Here we divided both the numerator and the denominator of this number by 3. I should find out that 12 over 3 is 4 and 21 over 3 is 7. So if you find out that sine alpha equals to 2 over square root of 7, in the next step we implemented the law of sines. This big triangle, triangle ABC. So pinch quickly on the law of sines. The law of sines is true in any triangle. This is triangle ABC that could be any triangle. We know that the length of side AB is AC, side AC equals to B units in itself, side BC equals to A units in itself. This is angle BAC, is equals to capital A divided inside. This is angle ACB, is equals to capital C divided in size, and this is angle ABC, is equals to capital B divided in size. And this triangle ABC is blocked by this circle. The radius of this circle is R. So according to the law of sines, in this drawing, the following equation is to A over sine A equals to B over sine B equals to C over sine C. And this is equals to also to R. So we can implement the law of sines. Now, triangle ABC. Why? Because we have here triangle ABC that is described by this circle. Why it is described by this circle? Because all the three vertices of triangle ABC lie on the circle itself. So, if you implement the law of sines in this triangle ABC, we get that CB or sinus alpha equals to 2R. Again, CB over sinus alpha equals to 2R. According to the law of sines, triangle ABC, CB over sinus alpha equals to 2R. We only found out that CB equals to the square root of 112. So, over sinus alpha. We only found out that sinus alpha equals to 2 over square root of 7. We found out that sinus alpha equals to 2 over square root of 7. So we have, according to the law of sines, CB over sinus alpha equals to 2R. CB is equal to 412. Sinus alpha is 2 over square root of 7 equals to 2R. So here, we move the square root of 7 to the numerator and 2 to the numerator. We move square root of 7 to the numerator and 2 to the denominator. And if we found out that we have, first of all, substitute 112 by 16 times 7. So here, 112 is 16 times 7 over 2 over square root of 7. The square root of 16 is 4, so we took 16 out of the root, so inside the root we have to leave 7. So today if you found out that we have here 4 times square root of 7 over square root of 7. So here we move square root of 7 to the numerator and 2 to the denominator. And we found out that we have here again square root of 16 is 4. So we took 4 out of the root. So inside the root we have to leave square root of 7. So we have 4 times square root of 7 over 2 over square root of 7. So we moved the square root of 7 to the numerator and 2 to the denominator. So in total we found out that 4 times square root of 7 times square root of 7 over x equals to 2r. Square root of 7 times square root of 7 is 7. We have 4 over 2 is 2. So total we have here, this is the equation, 2 times 7 equals to 2r. We have 2 times square root of 7 times square root of 7 equals to 2r. We have square root of 7 times square root of 7 is 7. So here we have 2 times 7. And this equals to, again, square root of 7 times square root of 7 is 7. So in total this expression equals to 2 times 7 equals to 2r. Here we divided this equation by 2. And we found out that r equals to 7 units in step. So in total we found out that the radius of this circle that draws triangle ABC, the radius r equals to 7 units in its length. Finish to repeat on the first question, the next time repeat on the solution of the second question. In the second question, our task is to find out the area of this semicircle. So in the drawing we have a semicircle. This is a right angle. This is answer PQ that is equals to 16 units in itself. This is answer PC that is equals to 21 units in itself. We also know that AC equals to 7 units in itself. Again, our task is to find out the area of this semicircle APQB. So first of all, we define the radius of this semicircle as R. So AO equals to R, and the diameter, we define the radius of this semicircle as X. Okay, so the radius AO is X, therefore the diameter AB is 2X. Again, the radius of the semicircle is X, therefore the diameter AB is 2X. Therefore the missing line side CB equals to AB minus AC. Again, AB minus AC equals to CB. CB equals to AB minus AC. So CB equals to AB, this is 2x, this is the diameter, that is 2x, minus AC is 7, AC is 7. So to that, if you found out that CB equals to 2x minus 7 units in its length. This is the answer of CB equals to 2x minus 7 units in its length. So in the next step, we completed this semicircle to a circle, and then we extended line segment PC by sideline until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. So we have here chord PM, intersection chord AB at point C. Again, chord PM, intersection chord AB at point C. Therefore, we can implement here rule 65. So let's pick here rule 65. So according to rule 65, if chord AB intersects with chord CD at point O, then the following equation is true. If chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Okay, we have the line in second. This is chord AB that intersects with chord CD at point O. So this line, the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So what I mentioned before, we can implement rule 65 in our drawing. Why? Because we have called PM that intersects with called AB at point C. Again, called PM intersects with called AB at point C. Therefore, according to Rule 65, again in our drawing, called AB intersects with called PM at point C. Therefore, the equation is so AC times CP equals to PC times CM. Again, AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. Only Rule 65. AC is 7. CP is 2x, CB is 2x minus 7, PC is 21, and CM is 8. So total, if you want to know that according to Rule 65, the following value is 2. 7 times 2x times 7 equals to 21a. Here we divided the equation by 7, and we found out that 2x minus 7 equals to 21a over 7 is 3a. So 2x minus 7 equals to 3a. Here we added 7 to this equation, and we found out that 2x equals to 3a plus 7. In the next step, we join points Q and M together by straight line. By joining points Q and M, we created the rectangle PQM. This is peripheral QPM. According to what is given in the equation, peripheral angle QPM is a right angle. Peripheral angle QPM subtend on chord MN. Again, peripheral angle QPM subtend on chord MQM. Again, peripheral angle QPM subtend on chord QM. And it's equal to 90 degrees inside. So here we can implement Rule 5. Basically, we can Rule 5. Any peripheral angle is equal to 90 degrees inside, must subtend on the diameter of the circle. In the drawing, we have a circle. This is peripheral angle MAN that subtend on chord MN. Again, this is peripheral angle MAN that is right angle. And therefore, it must subtend on the diameter of the circle. And indeed, peripheral angle MAN subtend on chord MN that is the diameter of the circle. So according to this Rule 5, any peripheral angle that is equal to 90 degrees inside must subtend on the diameter of the circle. We have here peripheral angle QPM that equals to 90 degrees inside, and therefore it must subtend on the diameter of the circle. Peripheral angle QPM subtend on chord QM, therefore chord QM must be the diameter of the circle according to Rule 5. QM is the diameter of the circle. The diameter of the circle equals to 2x. So in the next step, we implemented the Pythagoras theorem on this great triangle, MPQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the surfaces of the perpendiculars. So this great triangle MPQ, according to the Pythagoras theorem, QM squared, this is the square of the hypotenuse, equals to PQ squared plus PM squared. Repeat again, this great triangle QPM, according to the Pythagoras theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. QM is the diameter of this circle, that equals to 2x. Therefore, QM squared equals to 2x squared, and equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256, plus PM squared. PM is 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, we found out that 2x squared equals to 256 plus 21 plus 8 squared. We already found out that 2x equals to 3a plus 7. So 2x by 3a plus 7. What is 2x squared? So it is 3a plus 7 squared. And it equals to 256. We open the brackets here. 21 plus a squared equals to 21 squared, that is 441, plus a squared, plus 2 times 21 times 8, that is 42a. So total, we found out that 3a plus 7 squared equals to 256, plus 441, plus a squared, plus 42a. We open, so in total, 3a plus 7 squared equals to 256 plus 441 is 697 plus a squared plus 42a. open the brackets here. 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a times 7 is 42a. On the other side of the equation, we have 697 plus a squared plus 42a. So here we subtract a squared from this equation, so 9a squared minus a squared is 8a squared. We have 42a on both sides of this equation, so 42a will get cancelled. So in total we found out that 8a squared equals to, here we have 697 minus, here we have 8a squared equals to 49 plus 687. So here subtracted 49 from the equation, we found out that inside of the equation we have to leave 8a squared. 697 minus 49 is 648. So in total we found out that 8a squared equals to 648. Here we divided this equation by 8 and we found out that a squared equals to 648 over 8 is 81. So a squared equals to 81. Here we go to all those equations and we found out that a squared equals to the square root of 81, that is 9. We already found out that 2x equals to 3a plus 7. So put this equation here. 2x equals to 3a plus 7. So 2x equals to 3a. A is 3, so 3a is 9. So 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So 2x equals to 34. Here we divided the equation by 2. And we found out that x equals to 34 over 2 is 17. So we found out that the radius of this semicircle equals to x, and x equals to 17 is in itself. Our test is to find out the area of this semicircle. Because of the fact that the radius of this semicircle is x, then the area must be equal to pi x squared over 2. The area of the semicircle equals to pi x squared over 2. X is 17, therefore x squared is 17 squared. And x squared is 17 squared, so in total the area of the semicircle equals to pi times 17 squared over 2. So 17 squared is 289, so in total the area of the semicircle equals to 289 pi over 2 squared in size. In terms of numbers, the area of the semicircle equals to 453.96 squared in size. But again, in total, if you found out that the area of this semicircle, that is the area that we are looking for this equation, is equals to either 289 pi over 2 squared in size. In terms of numbers, the area of this semicircle equals to 453.96 squared in size. Okay, thank you very much.